NLU part and NLG part are very difficult, and I'll explain what goes behind. Um, NLU, the Natural Language Understanding, is actually real hallmark, real test of AI, artificial intelligence. Can anybody just voice out if they have heard of Turing test? Anybody? They can unmute and just say yes, no. Anybody heard of Turing test? Hello, can you still hear me?
Yes, sir. Yes, sir.
Yeah, can you just see if anybody can answer this? I thought this would be interactive, but I think there are limitations, I guess. This is faculty development, right? So all are faculties?
Yes, yes, sir.
Okay. Anybody who is from computer science background and knows what is Turing test? Anyway, I'll explain. So basically, if you're having a dialogue, having chat, say you're chatting with something. No? So you're sitting at one place, and there is a board in between, a partition, and behind the partition, there is something, and you are chatting with that thing, right? And whatever you are chatting to, if you are not able to distinguish that is it a person chatting or is it a computer, meaning software chatting. If you cannot make out, if you cannot distinguish, then AI has arrived. Got the understanding? So the system is so developed that it is almost human-like. It is like having a human intelligence. So that's the test of that AI has arrived. And chatbots are getting or trying to get there as far as human intelligence goes. They want to be as natural as possible, right? So that's the idea. I'll quickly skim over. Chatbots are there from decades in 1960s, as I've mentioned here. I'll share this presentation with you for later reference, but I'll quickly go over history and I want to cover the core part. So some of the things that you may have heard, IBM Watson, Siri, Alexa, Google, Cortana, that we have in our mobile phones also. This is what is the state of the art. This is how chatbots have come along. Chatbots are just these voice assistants as well as some messenger-like applications also, which are automatic. Normal WhatsApp is not chatbot because the other person is actually another human. But in case of chatbots, the other person is a computer system. So that is the distinction. And these are some popular things, as you may know. Alexa, Siri, Cortana, Google Now. But now that if you want to develop your own chatbot, what is needed? Of course, you need a lot of language understanding, natural language processing skills, because you're processing language, right? So there are some ready platforms which are available. Um, which can help in preparing this chatbot thing. And I'll go through some of the chatbots platforms. Main distinction is earlier there were rule-based chatbots, and now there are ML-based chatbots. Rule-based meaning they already decide how the conversation will go. It's almost like a decision tree. All right. Then there's a predefined workflow. After this question, you'll ask this question, get answer. After this, you'll ask this question, get this. So all is hard coded. But nowadays, these cases are too many. That's why ML-based chatbots, machine learning-based chatbots have come into play, and one of them is called as Raza, which we will see today. So while there is popularity of chatbots, they're autonomous, meaning they are on their own. They don't need human assistance, right? So that's why they're always available 24/7, all days. They can drive conversation. They can take you to different paths to finish the query. Imagine you are booking, say, aeroplane, you are travel from Mumbai to Chennai. It will ask you, where are you starting from? Where are you in? What is your destination? What is the date? Do you want economy or business class? All this it will ask. And once all the answers are there, then it will book the flight, right? So this is what chatbot does. And it can handle millions of requests. So that's why they are very popular. Challenges, of course, there are challenges because NLP, natural language processing, is very, very difficult. So getting chatbot to work is extremely hard. Plus, there is security issue. If you're asking healthcare related question, your salary related questions, then of course this is sensitive data, and we have to be sensitive, rather careful about that data, security of the data. So pros of chatbot: anytime, anywhere, scalable, consistent. It doesn't get bored, right? It will always do a similar job and not get bored. And it can, of course, gather data for further machine learning applications. Cons, the disadvantage: NLU, natural language understanding, is very, very hard. Nobody can replace human understanding yet, at least in the language. So it is hard, but at least some basic interactions chatbots can handle. It can be risky, as I said, because of the data, and it can, if you don't design it well, then it can do any. It can go anywhere. Plus, it understands only specific domains. Say if it is a flight booking chatbot or a banking chatbot, it will do only that, and it won't ask you any questions related to music or art, right? Not like a human person, which can answer multiple domains. But chatbots are typically single domain chatbots. Um, I'll wait here for a second and see if there are any questions. Now, I've done the introduction part, some evolution part. Now we'll go a little more technical and give you survey of what platforms are available and what do they do. Anybody? Uh, any questions so far? Just so that I'm just confirming that you are able to hear me and see me. Not that you have to answer. Any questions so far? Chaya madam, can you unmute and say something? Not able to hear you. Okay. Can someone else answer if there are any questions so far?
So just given just more detail about the rule-based and ML-based difference
Yeah.
actually in short.
Okay. Okay. So rule-based is when the interaction is hard-coded, predefined. That after this, I will ask this question, after this, I will ask this question. So that is predefined. But in case of ML, machine learning based, some basic training is given, but then it can ask what is the current prediction of the next question. So ML based is machine learning based and not rule based. That's the basic difference again with machine learning and traditional programming. In traditional programming, you write the logic, whereas in machine learning, the logic is evolved based on the training data. So Raza, that we will see is machine learning based chatbot, which you will understand that way. Is that okay?
Yes, sir. Yes, sir.
Yeah, I'll go ahead quickly now. Now that only 13 minutes are left. Maybe I'll stretch it a bit. I hope some of you are still available. Um, so these are some of the, so what is a chatbot platform? It gives you this facility of NLU as well as NLG in some cases, where when you type in some sentence, it does the classification, meaning the intent classification, entity extraction, those things which are briefly mentioned. I will explain them a little more later. That thing it gives you dialogue state management. From this state, what is the next question state that I have to go. So that you can configure there, and the natural language generation. So these are a couple of things that the platform is supposed to provide. And these are some of the platforms that are currently available. Of course, these are very few that I've mentioned here. There are quite a few. I'll wait here for a second so that you can read. So all these big companies, they have their own chatbot platforms. Dialogflow, Vid.ai, Watson, you might have heard, Microsoft, Luis, Amazon Alexa, you might have heard, that's Lex, and Raza. So I won't go through each of them now, but main distinction is all these above platforms, Dialogflow, Vid, Watson, Luis, Lex, these are over the internet platforms, meaning when you are building a chatbot, you type in some sentence, some query, that query goes to their server over internet, which is then analyzed there. And the further processing happens. So the actual logic or actual chatbot resides on their site. And then it generates the answer and gives you back. Got it? But Raza, the one that I've mentioned at the last here, is very different. It's actually a fully local chatbot, meaning whatever you chatbot that you have developed, if you type in something, the whole processing happens locally in your machine, and the answer is generated and then given back to you. So, what's the main advantage? Main advantage of Rasa in this case would be that complete security. Nothing is going over internet. So if you have some sensitive data, it resides locally. But what is the advantage of other systems? If there are some new enhancements, they can automatically be there, right? Because anyway, the sentence is going to the server. Server can update the models, the deep learning models, and do it. Of course, in Reza, you can upgrade the system later and get the newer models. So this is the main difference. So these are some popular chatbot platforms. I would go over each of them. Uh, okay. So I'll go a little more deep in Raza chatbot architecture. And by now you should be knowing the NLU part. So whenever a sentence is typed, the first part, as I mentioned, is NLU. It does intent identification or intent classification and entity extraction. So that is the top part that I've shown here. Once that is done, then either you do database query or you decide if there is anything left to be asked. That is the dialogue management. That dialogue management is called Raza Core, and the NLU part is of course called Raza NLU. Once the core thing is done, then you get the answer. Okay? So that's the rough architecture for Raza. I'll just mention machine learning and deep learning related aspects of Raza architecture for which this whole FDP is being taken. So I'll mention those things. Okay. Um, so what is NLU? As I mentioned, given a sentence, given a query, can you identify its intent and entities? So like, say a sentence like, I have a new address, it's something something San Francisco, isn't it? So what are the entities here? The address, because the intent is that address change, right? This is what the intent would be, change of address kind of situation. And the new address, right, is the entity. So once we are clear what is the intent, what is the entity, any guesses in a chatbot like system, how intent could be identified, and you have to answer in terms of which machine learning algorithm could be used for intent classification. So I have multiple intents. This could be change of address, give me bank balance, uh, delivery problem. These are intents, right? And entities are actually the arguments to this function. So account number, new address, date, my destination, my source city. These are the entities. If you're clear, what algorithm, my question is, what machine learning algorithm could be used to do intent classification? Any idea? I'll wait here for a second. Anybody?
So data mining a priori.
No. Some basic machine learning algorithm would do. Okay, it is basically a simple classification. There are different intents, so it's multi-class classification, of course, done using text. I'll explain that later. And what could be entity extraction? Anybody who has worked in NLP, what could be the algorithm behind entity extraction? That is discovering address, date, person name. What could be that algorithm? Anybody? Sorry that you are still a faculty. I'm asking you a question like a student, but just to see if you are able to understand what I'm speaking. What could be anybody working in NLP, natural language processing? What could be the algorithm behind extracting person name, address, date? What is it called? Okay. Now that this is not a physical class, I cannot point at that you speak and stand up and speak, but still, the algorithm is called as named entity recognition. So like POS, parts of speech, there is another algorithm named entity recognition. These are the algorithms used. So what happens in intent classification? Given sentences, you do vectorization like TF, IDF, word to vec, and do intent classification. So for this sentence, it's classified as request whether, isn't it? Can you all see the screen? Maybe I'll zoom it up a bit.
Yes, sir.
Okay,
Yes. Yes, sir.
sentence is like, what's the weather like tomorrow? What could be its intent? Request weather. So these are some predefined intents, and I have to classify my given sentence into this. Because with this, then I will fire the query. And what could be entity here? Anybody? In this sentence, the intent is request whether. What could be the entity here? Any guesses?
Whether.
No. Request weather is already achieved. That somebody wants to request a weather. Of what? Of tomorrow. So tomorrow is like a date-like thing, right? So what would be my SQL query or database query? Request weather given the argument tomorrow, meaning tomorrow's date, isn't it? With this, I should be able to fetch tomorrow's weather from database. Got it? That's the main idea. First, find the function to call request weather and give some argument of what tomorrow, today, day after tomorrow. These are the arguments. So uh, multi-class classification is used, machine learning algorithm for intent classification. And as these things you may be knowing, SVM, naive Bayes, logistic regression. These are some of the things which are used for intent classification. And vectorization is done by TF, IDF, or word to vec, or glove, any other method. Now, entity extraction. Given a sentence, this sentence, where can I get burrito in whatever second? This is city names in Pune. Where can I get burrito in Pune? What are entities? What would be the intent here? Find hotel, isn't it? Find hotel could be the intent here, and entities could be of what? Burrito and location in Pune. So this is how a given sentence in a chatbot is actually structured. Meaning, whole sentence is useless that way. This core information is important. Find hotel, burrito, Pune. These three things are enough, right? Then you can fire database query. So this is how chatbot works. Maybe that's the core idea actually of this presentation today. And maybe we can move a little faster now. This is the whole structure. And if you're familiar with NLP, this is the standard pipeline that happens. But it's NLU is very hard. Say if you have got a sentence like this, no, I don't want sushi. Now, if the intent classifies it as a find hotel and argument sushi, would that be good? No, right? Actually, the person doesn't want sushi. So an additional qualifier has to be sent. Non-sushi restaurants or find hotel and say non-sushi. So meaning anything else, right? So NLU and people can type in anything. Finding negation is very hard. I think I'll probably make it a full screen. Another state is dialogue management. Now that you have, we'll go back to our own example, flight booking. So you want to book a flight from Mumbai to Chennai. First question is, from where? So then you type in Mumbai. Then the next question could be, to where? Chennai. On what date? So this is sequence of questions that are being asked, right? So these are different states. Unless source, destination, date, economy, and few other things are not clear, we cannot do booking. So this is what is called a state management. It is driving the conversation, and this is handled by this. So set of questions, one after another. And then again, and this, if you do it rule-based way, you would have to write these kind of diagrams. From this question, go to this, go to this. You can also go to this. This is a very big mess. So that's why machine learning-based dialogue systems have come. So they predict which is the most likely next state. So rule-based and then machine learning-based, this is the biggest difference. Uh, so state machine. So again, I'll wait here for a second. What could be a deep learning algorithm, let me just say, that can be useful in predicting the next state? Now that you have done 1 week of deep learning, any idea? What could be that method used to predict the next state? Any answers?
So based upon the current state and current input, so we can predict the next state. Okay, that is also thing. So based upon the current state and current input.
Which architecture I'm asking actually?
Okay.
Which deep learning algorithm could be useful here? Have you done RNNs, recurrent neural networks? Right, these are actually used for predicting the next state. So a given set of sequences, previous states, then you go ahead and predict what the next state would be. So these are the basic things I wanted to mention. Maybe if you are interested, I'll directly switch to Raza. And I will suggest after this lecture, if at all you are interested in building chatbots, Raza is a good system because it's free and open source. That's why I'm talking about it. Others, some of them are actually paid. And academically also it is good for students because they just can download and use it freely. Maybe I'll directly go to, I'll share these notes with you. Basically, if you know about Python, you have to just say pip install Raza and everything will get installed. Okay. And then a few other things, I'll share the installation instructions. Okay. I think we are still past time. If you would be interested in seeing how that looks, how it's a very command line. You can of course have a UI chatbot window like thing, but I'll show you the academic version. It's very easy to create. You create a directory and inside you just say on command line say Raza init. And it develops a very simple chatbot for you. Everything free, open source. And maybe I'll show you how running of it looks. Can you all see my command line window?
Yes, sir. Yes, sir.
Okay, let me just show you. It's very simple, maybe just a couple of lines of interaction. Maybe I'll increase the font a bit. Um, can you all see the screen?
Yes, sir, it clear visible.
Yeah. Oh, sorry. Just a minute. Um, as you all are from academic background, doing command line should not be an issue for you, I guess. Yeah, it's basically loading standard models. It is used for intent classification, entity extraction, dialog state management. Um, of course, this is a command line view. You can build UI on top of it also. Um, so I've just said, and can you see the blue reply from chatbot? Says, hey, how are you?
Yes.
I'm saying, say great. Oh, then it says great, carry on. And I'm now surprised. I'm doing a Turing test. Are you a human now? Are you a human? No, it says, oh, I'm a bot powered by us. So this is how you can build interactions. I'll stop for now. And what it gives you some files ready with which you can start as basic chatbot, and then you can change these things and build your own chatbot of different domains. If you go to Reza website, lots of types of chatbots have been built and all open source. In the sense, you can see the source code. So this is what I wanted to cover. I would have loved to cover more deeper machine learning and deep learning, but with the want of time, I'm fastening up, doing it fast. So what are the takeaways uh, from this lecture? Chatbots or conversational AI is going to go very big, and I would suggest faculties to be familiar with this technology, mainly natural language processing, because even job market wise, research wise, this is very difficult area that everybody can go in. If you're a little smart, then and if you develop expertise in it, there is a lot of demand, in my opinion. And language, as you know, is very hard. So more and more research is needed. Another set of research needed would be this, whatever you have seen so far is English. There's immense potential in doing, say, Indian languages, isn't it? So Indian language-based chatbots, a lot of demand, as you can see. If you want to do railway booking via chatbot in Marathi, then there'll be immense market available. So knowing chatbot-related technologies is important. So this is what I wanted to cover. I know this is a little rush, but I thought this could be useful. Any questions? No, I'll stop sharing my screen, or maybe, yeah. Yeah, please go ahead.
Sir, am I audible? Am I
Yes, very much.
Sir, you can cover, if time permits, you can cover other contents also, sir.
Okay, maybe I'll cover the intent and intent classification and entity extraction, little more details,
Yes,
if
sir.
you all okay. So these are basically two machine learning related algorithms,
Yes.
which is the topic of your FDP.
Yes, sir.
That part in more details. Okay. This whole slide would be enough for this. Whenever...
Sorry to interrupt you.
yeah.
Can you please share your PPTs with us? It will be very much beneficial
Yes.
for...
I will be sharing all the content with you, with Chaya madam, and she'll send it to you.
Okay, sir. Thank you so much.
Okay. Here we can go a little deep as far as machine learning and deep learning goes. Say a sentence comes to us like this: what's the weather like tomorrow? Then what all happens in the background is what I'll explain now. And it's very challenging thing. So first thing is, of course, whatever we are doing is called natural language understanding. Now, the first task is what is called as intent classification. Now, assume that this is a weather chatbot. What all types of intents could be there? Request weather, isn't it? Ask for yesterday's request weather, meaning predict weather, what is happening tomorrow, or tell me about rains, tell me about the temperature, uh, tell me if there is thunderstorm coming. So these types of intents could be there. These are defined by us, the chatbot developer. So given a sentence, out of my set 10 intents, which matches the most? This is intent classification. This is like classification, any other classification. Given an email, is it a spam or not spam? Simple, right? That's a binary classification, spam, not spam. But here intents are not just two, many intents. So given a sentence, is it a request weather, a request temperature, predict temperature, predict rain? Which kind of intent is it matching to? So this is first problem, intent classification. This being a machine learning problem, what kind of training data it would need? Let me ask you. It's a supervised problem, right? Classification is a supervised problem. What would be training data for this algorithm? Anybody? Sorry that you have asked me to go deep, and I'll ask you questions now. Uh, so what is that? What could be its training data? Inputs are sentences and outputs are intents. That's it. So this is how training data would be fed, isn't it? And what happens in classification? A sentence cannot be fed to SVM, right? Or a naive-based algorithm classifier. You have to convert it to numbers, and the thing is called as vectorization. Right? You do word-to-vec conversion or TF-IDF conversion and make a vector out of it, meaning numbers. Then a model is trained. So this is what is intent classification. And another thing that I mentioned, entity extraction. So in this sentence, what's the weather like tomorrow? You can see the bottom block. I want to extract the date part. Now the same sentence can come as, what is the weather like? What was the weather like yesterday? Now the intent is same, request weather, but the argument has changed. From tomorrow, it is now yesterday. So knowing the argument to the function is important. So we want to extract the date part of it. Now here the date word is tomorrow. And this is what is called as entity extraction. In NLP, natural language processing, given a sentence, you can find out pause, meaning parts of speech, whether it is a noun, pronoun, verb, adjective, isn't it? On top of it, we can find out whether it is a person, whether it is a date, organization, those things, and that algorithm is called named entity recognition. And this can be done rule-based way, the chunker-based way, or machine learning-based way also. Simple, given a sentence, which are the date words, simple idea, right? So one sentence can have tomorrow, the similar sentence can have yesterday. So if I can understand tomorrow and yesterday to my database, I can say request weather tomorrow, request weather yesterday. That's enough, right? For a database to fetch me the actual information. So this is how a given sentence is broken before sending to database query. By the way, there is just no magic possible. Given a sentence, we have to do database query, the weather database, isn't it? So this is how a sentence is broken into intents and entities. And which are the popular algorithms for named entity recognition? One is hidden Markov model, or even the RNNs, LSTMs, which are sequence-based, isn't it? Unless I say, what's the weather like? The next word is likely to be a date only. Right? This is how training data is fed for a sequence analyzer. Right? I have thousands of sentences like that. What's the weather like tomorrow? What's the weather like yesterday? What's the weather like day after tomorrow? Then it gets, because the next date is of a date type, isn't it? So this is how a sequence modeler predicts date. And similarly, it can predict for different training data, person, organization, city, country. All those models are already built by many libraries like Spacey, NLTK, if you have heard. These are ready libraries available. So such algorithms are used. Is that explanation enough?
Yes, sir.
Okay, okay. So I'll wait. If there are any other questions, feel free to ask. We have passed.
Sir, I have one question. So we were
Yes,
talking about the natural language process, right? So if you just
yes.
consider, if suppose whatever our local languages are there and like that, so is there any change based upon that local language in their architecture or algorithms and like that?
Overall, the architecture won't change. But the actual training data with which intent classification has happened, or NER, named entity recognition, has happened, will change, of course. At a given sentence, I hope everybody understands Marathi. Udya Havaman Kaya hai. Now this Havaman will tell you what's the intent, right? Request Havaman Kaya. And Udya is the word that I have to capture. So English NER model won't capture the Udya part, right? It has to be built using Marathi language corpus. So finding entities in local language, Marathi, Hindi, or whichever, we need a language specific NER, isn't it? Then only we should be able to. So that's a big task. That's a very generic task. For Indian languages, building NER system, named entity recognition, is a big task. You need big corpus. You have to annotate it that these are the date words, train it, and then only it can predict. And I believe quite a few research institutes in India are trying to build such systems. I've seen some things for Bengali for sure, and of course a few other languages. So we have to build language-specific models. But the overall architecture workflow is similar. Given a sentence, find intent, find entities, do database query, get the answer, send it. That workflow doesn't change. Have I answered your question?
Yes, yes, sir.
Okay.
Sir, there is a question in the chat box.
Okay.
They want a demo for any bot, sir. Participant.
Actually, we just showed one, a small one. Were you there?
I think
But that's of course a command line.
yes, sir.
I haven't got anything which is having UI, meaning a window-like thing. But actually, I'll do one thing. I'll request you if you can note down. Maybe I can put it in a chat window. I have a GitHub repository. Maybe I'll type it here. If you go to GitHub, this Yogesh SK is mine. So type in Google GitHub these two words, and you will see a GitHub repository. And I've built a couple of chatbots, and I've shown, and these are all free chatbots. You can download and start working on it. So I'll request you to go there if you're familiar with GitHub, download, and see a chatbot with a window. You can type in and see how that works. But the interaction is very similar to what I showed command line. It's just that it's in UI. It looks nice. But the real part, NLP part, is just the same.
Sir, you want to give recent work in the industry, or you want to give some message to the faculty?
Yes, actually, there is a lot of need in natural language processing, and I'll just give you one example. Can you all see my screen? This is how the repository looks like,
Yes, sir.
and
Yes.
I've got two chatbots here. If you're interested, or any of your students, at least probably masters or PhD students, are interested in developing chatbots. Uh, Meaning it's not a very simple thing to do, doing vectorization, intent classification. So I've built a very basic framework called FAQ chatbot, frequently asked questions, right? So if you have a FAQ, say admissions to college, if this question comes, this is the answer. This question comes, this is the answer. This is all ready, right? If you convert this knowledge base to in a chatbot format, then the chatbot can answer at least these basic questions. What are the fees for FY admission? What is the intent here? Request fees. And what is the argument here? FY. That query can go to database, get you whatever, 20,000, and it will show in chatbot. So such processing is very, very useful. So for your master students or PhD students who want to work in this. For research, very important area is say Indian languages NER. That is very, very complex problem, and I think it's PhD worth problem. So for faculty and students, this is area for actual development, money making, as well as research. So this is a very basic framework I have put. You can download the source code free and start working on it. Another thing that I've developed is called a GST FAQ chatbot. Just as an example, people have a lot of queries about GSTs. Which are the items in 5%? Which are the items in 12%? Right? So this chatbot tries to answer. And it looks like this. And the source code is basically here. And maybe let me just see. Actually, I've written an article on one of the sites called Analytics Vidya. Uh, Maybe I'll show you that article. How to develop a chatbot, step-by-step approach. Maybe I'll show you that how that chatbot looks. So although I cannot show it running, it will look like this. If you all can see my screen, this is the actually blog that I've written. Again, it is freely available. This is how intents are specified, entities are specified, and any of your research students. This is how it looks. Can you all see the screen?
Yes.
If you download the source code and run it, this is how it will look. So you can build a chatbot like this. So my suggestion to faculty as well as research students, go into NLP. There is a lot of scope.
Yes, sir.
Any other? By the way, if at all you want to contact me, I was going to say this. LinkedIn is the best way. If you just type in, say, in Google, Yogesh Kulkarni, my original domain was CAD. By the way, I'm a mechanical engineer. Came into software later and machine learning quite late. So my original domain is CAD, computer aided design. If you type in Yogesh Kulkarni CAD, this is the first link you will get in Google. And if you want, you can connect with me on LinkedIn if you have any other further queries. Yeah.
Sir, is there any some agencies funding for such research proposal? If you have any idea for?
Funding idea I do not have. But I think there should be something related to language processing or Indian languages processing.
Okay.
I think there's good team working in Triple IT Hyderabad,
Okay.
and I believe in Kanpur also. But I do not have any idea about the funding part.
Okay. Sir,
But commercially, if you have those skills or students, basically, then there is good requirement for NLP people, including my company, company I work for. So if you know good NLP, then there is a lot of scope. Not just chatbot, even simple document processing. Given a legal document, can you find parties in the contract, effective date, contract value, contract duration? Same idea, right? It's entity extraction only, but done on a legal document. There is another workflow, medical NER. Given doctor's notes, can we find which diseases are being talked about? What are the side effects being mentioned? Lot of applications for text mining. Um,
Participants, any queries?
Let me just see if there are. Okay. Yeah, if there are no questions, thank you, Chaya Madam, for the opportunity, and thanks to Diva Patil. I will share my notes with Chaya Madam later.
Sir, thank you very much, sir. Your session was very informative, and hoping this again, it will be a tie-up with our institute. So
Yeah.
it will be very thankful, and it's an honor for our organization being a eminent personality as a speaker for today's session, sir. Officially,
Thank you. Thank you.
Lakshman sir will give vote of thanks, sir. He's a session
Okay. No.
coordinator.
Okay, it my privileges to propose a vote of thanks. Thank you very much, sir, for informative session. So we have just started from basic, that is how to use the machine learning in chatbot. So you are just clear all the concept related to the chatbot based on rule-based as well as machine learning based, and you also provide more detail about the popular platforms and one of the open source Raja chatbot architecture. You also provide the more detail what is the role of natural language understanding, or we can say importance of understanding natural language. Sorry, importance of natural language understanding in chatbot design. So thank you very much for sir providing a detailed information on chatbot design and like that. You also provided some basic whatever your design in chatbot. So it will be very good help to start the chatbot design and like that. Thank you very much for your sharing the informative information on chatbot design. I also very thankful to all the participant for joining the session. Thank you very much, sir.
Okay. Thanks and bye.
Thank you, sir. Dear participants, next session will be at 11:30. Thank you.
Just one query, madam. Is it okay if I just mention on LinkedIn that I conducted this session and then share the screenshot?
Yes, sir. No.
Okay, no problem.
Thank
Thank you.
Thank you.